Steven. I'm with Hydro Innovations. We're here at the San Francisco Trade Show, and we've got a nice system set up here, completely water-cooled, that we want to show you. First, I'd like to go over the equipment list that we have all this running. We've got a chiller and with the built-in reservoir and pump outside, 3 horsepower, and inside we've got 6,000 watt lamps, 6 Icebox 8-inch. We also have a CO2 monitor running our Hydrogen Pro water-cooled CO2 generator. All our fans, the 2 max fans that we have that are pulling air through these reflectors, are all set up on a thermostat. This thermostat will speed the fans up and slow them down as cooling needed, and that's our air conditioning for this system. Everything in here is ran off of these 2 lines that come inside. We've also got a nutrient cooler, 6 digital ballasts. We also got all of our lights ran off a timer box. This is exactly the way a proper system should be set up. What we want to do is demonstrate how effective the air conditioning is with this unit, because not only are you cooling all the light from these reflectors, like I said, you're cooling everything in the entire tent, and this is off of 1 chiller, 1 pump, 1 reservoir. Couldn't get much more simple than this. In just a second, we're going to fire up all this equipment. It'll be a little bit noisy, but this is the only way we can show you guys the effectiveness of it. The first thing we got is the water flows through the Hydrogen Pro, and this is a water-cooled CO2 generator. This unit is plugged into our CO2 monitor and will be turned on and off with this monitor. As an accessory, we also have the ice cap. Your incoming water runs through it first and then through the hydrogen, and it takes the efficiency up from 86 to 98% on the lowest setting. It's a great product. We've got our 6 digital ballasts, which our air conditioning is also cooling. You got to consider that everything in this tent, even the radiant heat, is all cooled by the water. Right now, we don't have the chiller on. I want to show you guys how hot this air is coming out of this heat exchanger. "80 degrees coming out of the heat exchanger right now. We just turned this system on. In just a second, we're going to turn on the chiller and retake this reading. Okay, we're back. We've got the chiller up and running. We'll take this temperature again. 58 degrees. The air coming out of this ice box is 58 degrees. Now, what makes this work? Well, we've got our pressurized water line coming in. It's feeding our ice boxes. That's what's making these fins cold. And we simply have air blowing over them. We're water cooling an air-cooled system. It's not a water-cooled light. This is a little bit safer than the water jackets and the water being right on the bulbs. Also a little bit easier to install. The way this works is you've got incoming air coming through this reflector, passes over the icebox heat exchanger, through this reflector, another icebox heat exchanger, 3rd reflector. We have 1 MaxxFan 8-inch running this entire system, and it's hooked up to the last icebox. We recommend 1 icebox per reflector, and the reason we do that is because you can run 3 lights off of 1 icebox, but your water has to be so much colder to get the results that you want that it's really inefficient, and it's not going to save you any energy. This system is designed to save you energy, and yes, you're using power for the chiller, but chillers are so much more efficient than air conditioning. You're replacing your air conditioning. Even if you use this system with your air conditioner, you're still saving money because you're going to take that load off of your air conditioner and put it on the chiller. Chillers are 40% more efficient than air conditioners. And what that means is out of a 5-ton chiller, you're going to actually get 5 tons of cooling. But out of a 5-ton air conditioner, you're going to get 3.5 tons of cooling, and they use the same amount of power. That's an important point. These water-cooled systems, they work well and they're efficient. A lot of us use chillers to cool our nutrient reservoirs because we all know that the higher temperatures are bad for our root system on our hydroponic setups. So, you know, this system, we're showing you how to do 1 chiller, 1 pump, 1 reservoir. And this is the component here that you can use, a coil draped in the reservoir. It's going to take care of all your cooling needs for that as well. You can adjust the temperature of this water by adjusting the valve that's on the intake manifold. Your manifolds are the heart of the system. You can daisy chain 1 or 2 ice boxes together, but a proper setup should use a distribution manifold system. You see, we've got valves on each one of these supply lines. This is going to regulate the flow through your equipment. Some equipment you can run full bore with the water flow. Some equipment you may want to turn back, like our nutrient reservoir cooler. You know, you don't want it to be too cold. Now, what we've done is we've got a 1-inch line coming in, and we've got a 1.25 inch going back out. And that's really important. And the reason is because we want our manifold pressurized. And the reason we want that is that's what's going to give us even distribution through all the equipment. And we want no pressure on the backside, and that's how the system works. These are properly set up manifolds. One other little nice piece to this is there's an emergency bypass over here in the corner. What the emergency bypass does is in case your chiller goes down, you can turn off these two valves and come over here and turn on these two valves hooked up to city water and drain. So you can do drain to waste while your chiller is being repaired. This keeps you from having to shut your whole system down. This allows you to keep growing no matter what the conditions, and you have complete control over it no matter what happens. Just like any other air conditioning system, you need a way to regulate the temperature. And this is the Icebox thermostat. You plug your fans into this and you plug this into your wall. You've got a temperature probe that hangs in your room. You've got night and day settings. What this unit does is it speeds the fans up and slows them down as you need cooling. So what happens is during the on cycle, the fans will rev up until the room temperature is reached, and then it'll steadily slow the fan speeds down and to an idle once the temperature is reached. And the way this is set up with a photocell, you can actually set a night temperature, and at night the system will actually cut off. It will cut the fans completely off. And the reason we do that is because you never want to stop airflow through your reflectors during the on cycle. This is the Hydro Innovation CO2 monitor. This unit is meant to be affordable and simple to use. There's no digital display. It's just indicator lights. There's no adjustment on the detector. It starts at 1300 and it turns off at 1500. It's got a wall mount bracket and a Sensair CO2 detector inside. This unit is affordable because it's simple. It's not because it's cheap. These units retail for $349.